Good afternoon, everyone. Today we are going to discuss about operating system deeply activity based class. Okay, first we have to separate three different groups. So everyone tell, first all of you tell 1, 2, 3. Like if we divided our team into three big groups, first tell 1, 2, 3. Like that. Okay, the first question is, what are the storage structures we are using?
This app வந்து PC DRAM RAM random access memory DRAM dynamic random access
What are the storage devices we are using? Hi everyone, this is M.Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajalakshmi College of Arts and Science. In this series, we are going to see about computer system organization. So the computer system organization of your computer system is the processing unit, memory unit and input-output devices. So the processing unit controls all the functions of the computer system. It is the brain of the computer. For example, CPU, so central processing unit. So the main memory unit consists of two units. One is an arithmetic unit and the other is a logic unit. Input devices are those devices through which end user and send message to computer. For example, keyboard, mouse, etc. These are all the input devices. So output devices are those devices through which an end user get output from computer. For example, monitor. So scanner. So each device's controller in a charge of a specific type of devices. So the CPU and the device controllers can execute concurrently, competing for memory cycle to ensure orderly access to the shared memory. A memory controller is provided whose function is to synchronize access to the memory. Hardware may trigger an interrupt at any time by sending a signal to the CPU. Usually by way of the system bus, software may trigger and interrupt by executing a special operation called a system call. It's also called as a monitor call. Next we see the interrupt handling. So interrupts are an important part of a computer architecture. Each computer design has its own interrupt mechanism, but several functions are common. So the interrupt must transfer control to the appropriate interrupt service routine. So the straightforward method for handling this transfer would be to invoke a generic routine to examine the interrupt information. The routine in turn would call the interrupt specific handler. The interrupt routine is called indirectly to the table with no intermediate routine needed. Generally, the table of pointer is stored in low memory. So the first 100 are locations. These locations hold the address of the interrupt services routine. For the various devices, this array or interrupt vector for addresses is indexed by the unique device number given with the interrupt request to provide the address of the interrupt service routine for the interrupting device. So the interrupt architecture must also save the address of the interrupted instructions. After the interrupt is serviced, the served return address is loaded in the program counter and the interrupt computation resumes as to the interrupt had no occurred. So next we see the storage structure. So computer program must be in main memory. It's also called as a random access memory. So So it will be an executed one. Main memory is the only large storage area, millions to billions of bytes, that the processor can access directly, and dynamic the random access memory the processor can access directly. Next one is a dynamic random access memory. It is implemented in a semiconductor technology which forms an array of memory blocks. Typical instruction executions cycle first fetches an instruction from the memory and stores the instruction in the instruction register. Two possible reasons if you want to program and data to reside in main memory permanently. Main memory is usually too small to store all needs program and data permanently. Main memory is a volatile storage device. The losses it contains which power is turned off or otherwise lost. Next one is the storage devices. Basically, we want the program and data to reside in the main memory permanently. This arrangement is usually not possible for the following two reasons. So, main memory is usually too small to store all needed program and data permanently. Main memory is volatile storage devices that losses its. There are two types of storage devices. One is the volatile storage devices, another one is the non-volatile storage devices. So volatile storage devices, it losses its content when the power of the devices is removed. Non-volatile storage devices, it does not losses its contents when the power is removed. It holds the data when the power is removed. Next we see the I/O structure. So typical operation involves I/O request, direct memory access and interrupt handling. Storage is only one of many types of I/O devices within a computer. A large portion of operating system codes is dedicated to managing I/O, both because of the importance of the reliability and performance of a system and because of the varying system consists of CPUs and multiple devices controllers that are connected to a common bus. Each device controller is in charge of a specific type of devices. These are the I/O devices. So we come to the end of this section. I hope you enjoy this section. Thank you.